Hello friends, this video on Haloalkanes and Haloarenes part 8 is brought to you by examfear.com. No more fear from exam. So let's talk about the preparation of haloalkanes and haloarenes. So it is prepared from alcohol. Please note, haloarenes are not prepared from alcohol. Haloalkanes are prepared from free radical halogenation, from electrophilic substitution, from Sand-Mayer reaction, halogen exchange method, and from alkenes. In alkenes we have from addition of hydrogen halides, from addition of halogens. So we start with the preparation of preparation of haloalkanes from alcohol. And please note, this is used only for haloalkanes, not for haloarenes. The reaction is pretty simple actually. I have any alcohol, it can be primary, secondary or tertiary. I react this with HX and catalyst if required. Catalyst if required, I get RX and water. And this RX is my haloalkanes. So in this case we know that my tertiary alcohol is more reactive, right? Because this follows SN1 reaction. So my tertiary alcohol is more reactive. I'll show you why. Because if you see, this kind of carbocation is formed, right? And this is more stable carbocation, tertiary carbocation. So this is more reactive, so that doesn't need catalyst. But for primary and secondary, we need catalyst. That is nothing but ZnCl2 uses catalyst. Right. So in this case what happens is this OH group will be replaced by this X. The alcohol group is replaced by halogen. Correct. Let's take the example of HCl. So let's take HCl example. So here we'll replace OH with or OH minus with Cl minus. That's what we'll do here. So here again, since tertiary alcohol is very reactive, tertiary alcohol will react very well, but not the primary alcohol. So you'll see that the temperature also required is more for primary alcohol. But tertiary, if you take a tertiary alcohol here, you can add extra H here. This is my tertiary alcohol. I react with HCl even at 25 degrees Celsius. I get this compound. Right. So here my Cl minus will kick out this OH, and this is SN1 reaction actually. Why SN1 reaction? We have studied this in class 11. We'll again study, we'll revise that, because this steric hindrance here, right? So the HCl won't be able to attack on this OH, but OH will leave on its own because this is a stable carbocation, right? And it's a very slow process. And then Cl minus will take this position. This is a SN1 reaction. So if you see, what happens is I have this compound. You can add H here. So there will be very slow process. So in slow process, what will happen is this HCl, right, will have H plus and Cl minus ion here, right? So this HOH will be attracted towards this H plus, form water, right? So the compound it will form is this guy, OH and H, something like this, right? OH and H. This H will attack this oxygen here. Oxygen will have this group here. It will be a positive charge. So this whole thing will come out. This water, right, will come out. So it will be, you remove minus water from this, you get this carbocation. This carbocation. I drew in this fashion. It should be actually same actually, but not to confuse. This carbocation. And this is a slow process, very slow process, very slow process. Correct. Once this is done, I have a chlorine guy waiting here, because I have got this chlorine guy here waiting. This chlorine guy will attack this carbon and it will form this compound. Hope you understand. So I have this compound, tertiary alcohol, right? Since the medium was acidic, little H was there. So this oxygen wanted to attack this hydrogen and it became water plus here. It got rid of water, it became a cation, carbocation, that's stable compound, actually almost pretty stable. And then chlorine attacked this carbon with a plus charge and form this compound. Correct. Now let's see where my OH is replaced by Br. So in last case we were using HCl, right? So instead of, in this case, we'll not use HBr. So directly will not say ROH plus HBr. This will not say. I mean, we'll say that, but how to get HBr directly, right? HBr, to get HBr, what we do, we'll take NaBr and H2SO4. So what happens is, you have NaBr and H2SO4, they react to form HBr. And Na2SO4, you can write a balanced reaction. This is a balanced reaction. So we'll use this instead of HBr directly. First thing, so in case of HCl, we directly used HCl, but in case of HBr, we will not directly use HBr, but we'll use the solution of NaBr and H2SO4. Correct? Now, what we will do is, let's see the reaction now. So this is the compound. So I have, let's suppose my primary, let's take a primary alcohol, let's say CCOH. This is the primary alcohol. Let me write here hydrogen. Right, ethyl alcohol. So in this I'll add HBr. HBr is nothing but this solution I'll add. So I'm writing HBr because this solution will give me HBr, NaBr and H2SO4. I have to heat this now because it's primary alcohol now. So what will happen here also is a SN1 reaction. Why? I'll show you. Let's now prepare again HX or RBr from ROH. So here we'll use HBr. In fact, we don't use directly HBr, but we use this solution NaBr plus H2SO4. This gives me HBr and Na2SO4. So I'll use this solution instead of directly using HBr. You can write the balanced equation. Correct. Now if you notice here is HBr, if you talk about the reactivity, HI is more reactive, right? And then we have HBr, then we have HCl, then we have HF. This is more reactive. Correct? This is more reactive. Why? Because I is bigger in size. So this is more reactive. This is also reactive. This is less reactive. So with this you can say that Br minus is a stronger nucleophile than Cl minus. Also, let's take an example of CH3, CH2OH. So here we'll react with HBr. I'll write HBr, but instead of HBr you'll use this solution. So in this case Br minus is a stronger nucleophile. It will attack this carbon. Also it is a primary carbon, 1 degree. So it has space to attack. So it will follow SN2 mechanism. Correct? Because Br minus will attack and will kick this HOH out, and OH will attack, add with H plus and form water. So you'll get CH3, CH2Br and water, and it will follow SN2 mechanism. Correct? Why? Because this is primary alcohol. This is 1 degree and Br minus is strong nucleophile. So we'll discuss about SN1 and SN2 where we'll say why sometimes it goes for SN1 and sometimes it goes for SN2. This is an example of SN2 reaction where we are converting this ethyl alcohol into ethyl halide. Let's replace, we have something called ROH. We'll try to make it RI. So instead of here we'll use HI. Correct? So we'll have something like the reaction will be ROH plus HI will give RI plus H2O. Similar to this, but here if you see we have used H2SO4, but here H2SO4 will not be used. Why? Because H2SO4 sulfuric acid, you know, is a very strong acid, and you have I minus, it will oxidize I minus to I2. But we need I minus, right, for this reaction to happen. So what we'll do? So we'll use H3PO4. Please note, in this case, H3PO4 is used, phosphoric acid is used instead of H2SO4, because sulfuric acid is very strong acid and it will actually oxidize I minus to I2, and we want I minus, and as I told, I minus is very reactive, right? So even it gets it can be oxidized very easily. So here we'll use H3PO4 instead of H2SO4. Similar reaction will have, it can be SN1 or SN2 depending on its primary, secondary or tertiary alcohol we are using. But it will be a substitution reaction for sure. Correct. Now we'll see, we'll use PCl3 and PCl5 for converting alcohol to halides. PCl3 is generally used for higher alkanes, which are liquids. So the reaction is, let's take a bigger alkane, CH3, CH2, CH2. You can add more, actually I'll stop here, plus PCl3 if you add, so this becomes CH3, CH2, CH2Cl, and you get H3PO. This is the reaction, and this is liquid actually. PCl5 also you can use, you can have alcohol, use PCl5, it will give you RCl plus POCl3 and HCl. You can use red phosphorus also, and you can use any halide. You have ROH, you use red phosphorus and any halide. So this becomes RX. Or we can also use SOCl2. These reactions we'll see lot. RCl plus SO2 plus HCl. So if I want to convert alcohol to halide, this I can use red phosphorus with any halogen, or I can use SOCl2. I can also use PCl3 or PCl5. I can also use HBr, HI or HCl. So there are so many ways to convert normal alcohol, alkyl alcohol to haloalkanes. Correct? You can use SOCl2. You can use red phosphorus with a halogen. You can use PCl5, PCl3. You can use HI, you can use HBr, you can use HCl. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.